Okay, everybody, let's recap the lesson. So today we are on page 505. We're still talking about inverses. So in this little review, kind of like our warm-up, we want to solve for x. So solving for x is a little tricky because we know we're going to take a square root. We know we can take a square root. We're going to have two answers because of the x squared. So let's go ahead. I'm going to go plus 1, y plus 1 equals x squared, right? Plus 1. And then I'm going to square root both sides to get x by itself. Now, here's the thing. We know because the x squared, there has to be two answers, so it's plus or minus the square root of y plus 1 equals x. Okay? Now on the number 2, very similar. I'm going to multiply by 4 first, so I get rid of the 1 4. So multiply by 4 off of 4y equals x squared. And then I will get rid of the square by taking the square root. Okay? Now, we know the square root of 4 is 2, but there is no square root of y. It just has to stay the square root of y. And we have to remember that, again, there are two answers, so it's plus or minus, positive and negative, okay? Number 3, because it's a cube, you really don't have two answers, okay? So what we're going to do is cube root both sides. Cube root, right? Cube root both sides. So then we get the cube root of y equals x plus 4. Not plus or minus because cube root's either plus or minus, not both. And then minus 4, and we have the cube root of y minus 4 equals x. Okay, now how's that going to help us? Well, we're talking about inverses. So let's turn the page. And we know that with inverses, what we're going to do is we always switch x and y. So we take x squared, and for an inverse, we switch x and y. So it becomes, instead of y equals x squared, it's x equals y squared. And then we solve for y, okay? Square root. Again, we're taking the square root of a y squared plus or minus x, okay? Now, if we go to graph that, we took a look at graphing this graph, okay? With the plus or minus, the positive part is, here's the square root of x, but the negative part, y equals a negative square root of x, is this bottom part. We can't have that because this is not a function. So, we'll learn something called the horizontal line test. If your original graph fails a horizontal line test, meaning if goes through it and hits it more than once, there's two y values for this x value, it cannot work. So then if it fails the horizontal line test, it will fail an inverse. So this one does not have an inverse, But, so we talked more about this graph, okay? Then we talked about graphing the original. So here's my x values, my y values. If I plug these values in for x squared, and for x squared, we get the corresponding y value. So we graph that here in blue. This is our original. So then let's talk about the inverse. To do the inverse, we switch x and y. So all of these points just reverse. And here I wrote them down, reverse my points, and I graph this. Okay, again, the problem is this sideways graph is not an inverse. Okay, it's not a function. So we talked about how can we fix this. Well, what we want to do is fix it eventually, so it has a function. We talked about the domain of the blue all real numbers, the range greater than 0, greater than equals 0, x-intercepts and y-intercepts. But what we found was that the range and the domain of the inverse reverse. Okay, so the range becomes the domain. So the domain of the red graph is greater than equals 0. The range of the red graph is all real numbers, and the x and y-intercepts are the same. Okay, now we notice that the domain of the function is the range of the inverse, and the range of the function becomes the domain of the inverse. Now that makes sense because you're switching x and y. So if you switch x and y, you're switching everything. All of the domain and all of the range switch. Made sense to all of us, okay? Turn the page. Okay, wait a minute. We're going to change the domain. So what do we do right at the bat? We say, okay, we are going to change the domain. We're going to start with this, okay? We're going to let x only graph the part where x is greater than 0, okay? So if you graph the x, so this back half is not here anymore. So if the back half is not here anymore, you only graph the positive part, then the negative part of the inverse is not there. And then you have an inverse. So if you graph it with x squared, if x is greater than or equal to 0, then all of a sudden you have an inverse, okay? Then we looked at graphing them again, okay? We put it on the graph with the inverse, with a domain change of x is greater than or equal to 0 only. We graph the original without its negative. We graph its inverse without its negative, and all of a sudden it works. We have a function for the regular. We have a function for the regular graph, and we have a function for the inverse. Okay. Then we did the domain and range again. We noticed that the domain and range are reverses, okay? Now, does it have an inverse? No, it doesn't have an inverse because it reaches 0. Okay, that's what I have for you today, including a homework assignment. So I will see everybody tomorrow.